In this video we will discuss naive Bayes classifier. So, what is naive Bayes classifier? It is based on the Bayes theorem. We saw what is Bayes theorem in the last class, and it has a naive assumption, and we said that the features are independent, but all are related to the dependent value, right. So, all x1 is dependent to y, x2 is dependent to y, but x1 and x2 are independent events, that is the idea. So, to just imagine it is like this. If you want to imagine that facing the same Venn diagram, if it is x1, this is y, x and y are dependent, there is something called x2, there is x2 and there is something called x3, there are multiple dimensional features can be possible. It is not possible to explain in simple terms, but that is exactly what the Bayes theorem will do. Okay. Get that the imagination of the figure where there are features which are independent, but all dependent on one particular predictor or one particular dependent value. So, simple Bayes theorem is this, you remember that from the last video. Let us see how naive Bayes classifier can be used. So, this is simple example I created. If the attendance is in this percentage, attendance in percentage in the pass mark in midterm is this. So, let us see. So, attendance in percentage, pass marks in midterm, pass in midterm is yes, is pass or fail. So, yes or no, you pass the exam or not pass the exam. So, from this table we can construct a frequency table. What is frequency table? Frequency table is simple. Let us make a bins out of these values. Okay. I am going to 3 bins here, 40 to 60, 60 to 161 to 70 and 71 to 80 or above 80, 71 to like 80 and above. It is not just 80, it is 80 and above. Okay. So, I have the 3 bins here. Now, I need to compute x and y, s, how many people will pass in this 40 to 60, 1 yes, 1 no, 1 yes, 1 no. Okay, I should, okay, let us see the yes only, okay, only 2, there are 2 yes, okay, and let us see no, 40 to 51 no, 2 and 3, there are 3. Okay, it is just a frequency table you can construct from the given values. Okay. Here it is only one x and one y, it is like independent dependent variable here, and for 61 to 70 similarly there will be 61 to 70 there are 1 and 2 yes and 1 3 yes. Let us change this value to no 65 to no, then it will be like 2 and 1, and 71 and above it is only 175, that is x, that is good. So, if you count these numbers, total yes is 5, total no is 4, total numbers is 9. So, probability of yes is 5 by 9, probability of not pass is 4 by 9. Okay. That is a simple thing you can compute. Also, probability of 40 to 60 is 5 out of 9, 3 out of 9 and 1 out of 9. Okay. That is numbers also you can compute easily. So, this frequency table tells you what is the value of each bin and their corresponding yes and no probabilities. So, probability of yes is 5 by 9, probability of let us change this also just to be clarified. So, this will be no. So, probability of yes is 5 by 9 computed by this value, probability of no is 4 by 9 exactly, and probability of attendance 40 to 60 is the total number is 4 by 3 plus 2, that is 5 by 9, probability of 61 to 70 is again 3 by 9, 71 to 80 is 1 by 9. So, that is the probabilities you can compute from this table, like in the column wise, also in each row wise. That is the value you can get from the naive Bayes classifier. Let us use this to answer some questions. So, let us see, consider you have this table, kind of this is the table you got it from the given input variable, and we want to ask you question, what is the probability of passing the exam if a student's attendance is 64. Okay. What is the probability of student attendance 64 being passed the exam? Simply you can go ahead and see out of this 2 by 3. So, 2 by 3 is the possibility to get it, but exactly if you apply it in Bayes theorem also it will give the same answer. Let us see how it goes. So, write down the answers, check, apply in the Bayes theorem steps and find what are the events and write it down. After writing it down, resume the video to continue. So, if you apply the Bayes theorem, you want to know probability of passing the exam equal to S given attendance is 61 to 70. So, which means you have to say probability of attendance 620 given the students is passed, and probability of passing the exam also equal to Y divided by probability of attendance 61 to 70. So, probability of this so this probability, right, probability of attendance is 61 to 70 given the student passed the exam. That is exactly the student passed the exam is the students the 5 events the students can pass the exam, 5 students pass the exam, in that 2 of them are in the attendance 61 to 70 bracket. So, that is 2 by 5, okay. This is exactly this 2 divided by the total number 5, and probability of pass we have computed already 5 divided by 9, that is the value, and probability of in attendance 61 to 70 is this, right, the 3 numbers, 3 times the student is in this range. So, total number is this. This table is computed from the training value, the student. There is a new student coming in and asking what is the probability the student will pass exam if attendance is 61 to 70, what is the probability he will pass in the midterm. So, if you apply this 5 will cancel and 2 by 3 will be the answer. It is simple, you can compute directly from the table, but imagine there is not a one variable, there are 2-3 variables, then it will be a bit tricky. That is why we can use Bayes theorem there. So, this is a very simple example where we can apply Bayes theorem to solve this training and predicting which student will pass the exam in the midterm or not based on the attendance. Let us see how we can apply the Bayes theorem into multiple classes. In a multi-class problem C1, C2, C3 up to C1. So, instead of a class 1 there are multiple classes. It is not a pass or fail, it can be getting less than 30, more than 30 to 50, 50 to 80 and 80 to 100, something 4 classes, or student will drop out in first week, student will drop out in second week, something like that, or different classes you want to classify. If you want to classify in multi classes like C1, C2, C3 and you have multiple features, right, like interest or deadline of other works, or student sleeping at the time, or student is working on different activities, there are multiple features, or students engagement in the class, or students attendance, midsum marks, a lot of things are coming here. If you have that kind of multiple features and multiple classes to predict, it is called multivariate in the regression, but so if you have that kind of problem, simple Bayesian can be extended to solve this problem, that is probability of Ci, that is suppose for the class 1 probability of C1 given all the features A1, A2, A3 to AN is probability of Ci into Bayes theorem, simple Bayes theorem, probability of A1, A2 up to AN given the particular event divided by probability of all the event occurring. Okay. That is exactly the Bayes theorem application, this is exactly where you want to use a Bayes theorem. If you have this kind of equation, we had a naive assumption, you know, the assumption is that A1, A2 are independent, right, which means probability of computing this probability is easier. So, this is this. So, this is very simple to compute because we have naive assumption, that is A1, A2 all independent, which means probability of A1, A2, A2 all occurring given particular class C1 can be split into probability of A1 occurring given the label 1, probability of A2 occurring given the label 2, like similarly A3 by Ci till AN by Cn. Okay. If you have this kind of product rule, then you can make it as a simple product of probability of AIGA. So, product of all the features will occur given the particular event is for that this particular equation will be solved. If you have that, and you might have the probability of Ci already, and this is also nested, we will see how it happening. So, if you have this particular equation, it is easy to compute. Okay. This will compute probability of Ci given, suppose Ci equal to 1. Okay. Then we have to compute the same probability for Ci equal to 2, Ci equal to 3. Suppose we have 4 classes, we have to compute 4 different probabilities and find which one is higher, we have to pick that one. So, since we are comparing this Ci equal to 1, 2, 3, 4, what we can do, we can ignore this term. because this will be the common denominator in all the comparisons. So, we can ignore that. So, the naive Bayes classifier simplified is very simplified into a probability of all the event occurring given Ci, that is exactly this product rule, into probability of Ci, that is it. So, what you have to do is take the class 1, suppose if you want to do the for class 1 probability of C1 given all the features like A1 to A3, okay, A1, A2 and A3. It is simple product rule of product of probability of A1 I equal to 1 to 3 AI divided by C1 into probability of C1, that is it. It is very simple, you know, it is simple to compute. Similarly, you have to compute for probability of C2 given A1, A2 and all the 3 events occurs, probability of C3 given A1, A2, A3. If you compute all 3 probabilities and you have to pick the probability which is higher, that is a particular class of that particular given events. So, this is how you train the naive Bayes classifier. So, from the given input table input values, you have to compute all these values like probability of A1 given C1, probability of Ci, probability of A2 given C1. So, you have to compute that frequency table. If you have that particular frequency table, it is very easy to compute the new features. What is the probability of student pass the exam, not pass the exam, student get more than 30 marks, less than 30 marks, all this different classes can be classified. So, that is what all about naive Bayes classifier is. So, here is one simple example. This example is it's very simple example. Consider a student has passed in all other exams in previous semesters. Okay, he is taking a current semester course in one particular subject in your subject, and he has passed all the exams. If he passed, it is yes. If he is not passed, it is no, yes, no. And the students attendance also low, medium, high. We split into 3, maybe less than 30, 30 to 60, 60 to 100, something like that. You split into 3 bins and that is a bins value, it is a categorical variable. Then you have midterm marks also categorized to 35, 35 to 60 or more than 60, that is it, 3 bins. Given these values, we want to predict the y, x1, x2, x3, you have to predict y, that is will the student pass in the final exam or not. If it is pass, it is yes, if it is pass, if it is yes, it is no, it is no. So, the question is what is the cross probability of a student with a midterm mark equal to 55 and attendance is low and he has not passed in all other subjects. He has not passed in all other subjects. So, he has not passed all the subjects, might have passed 2 or 3 or missed 1 or 2 subjects, not passed the exams. Given this value, what is the probability? So, it is simple. So, what we are asking is probability of final exam is equal to yes, that is a class C1, C2. So, only one class here like and given the pass in all other subjects. So, other subject is no, that is A1, attendance is also low, that is A2, and midterm mark is 35 to 60, midterm mark is 35 to 60. What is the probability? So, if you can compute the frequency table from this figure, this table, you can compute this very simply, because it is simply the probability of passing, probability of passing the exam, that is 1, 2, 3, 4, that is how many 10 in the 3 years, 7 by 10. So, probability of yes equal to 7 by 10, and if you compute the probability of A1 given Ci. So, what is the probability of A1 is equal to no given this value. So, if you can compute that 3 values and you can simply substitute, you can get the probability of whether the student will pass the exam or not, right. So, that simple is naive Bayes classifier. Naive Bayes classifier is basically based on what to say the naive Bayes theorem and with a naive assumption, and it is computing the frequency tables and using that table to predict the future events. Thank you.